Hey there, I'm Matt. Welcome back to our instructional series. Today I'll show you how to take control of access, who can get in, what they can do, and when with Border Zero's powerful policy engine. Picture this. You've got a team spread across different locations, each needing secure access to your critical systems. Managing this securely can be a headache, right? That's where Border Zero steps in. With its policy engine, you can create tailored access rules that ensure security without compromising on efficiency. So what's a policy in Border Zero? Think of it like a modern-day firewall rule, but way smarter. Instead of just checking IP addresses and ports like a traditional firewall, Border Zero policies are all about identity and applications. It's a set of custom rules that decide who, based on their single sign-on identity, can access what specific resources and under what conditions. When I say conditions, I'm talking about things like where the user is located, whether that's a specific country or IP address, and even the time of day or dates. So whether you're protecting SSH servers, databases, Kubernetes clusters, or web services, these policies make sure only the right people get in and only when it's safe. All right, let's dive in and create our first policy. In the Border Zero portal, head over to the Policies section. So you'll notice we've got two options here, a regular policy and an organization-wide policy. Now you might be wondering, what's the difference? Well, an organization-wide policy will automatically apply to all your sockets. That's what we call services in Border Zero, including any new ones you add down the line. It's basically a one and done setup for everything, all in one go. On the other hand, regular policies need to be linked to specific sockets, giving you the flexibility to apply different rules to different services. This way, you can be really precise about which policies apply to which sockets. When a user tries to access a socket, Border Zero automatically checks all the policies attached to that specific socket. It evaluates the conditions of each policy, things like the user's identity, group membership, IP address, and more. If a policy's conditions match the user's context, Border Zero then remembers the permissions associated with that policy. Here's something important. A single socket can have multiple policies attached, and Border Zero will evaluate all of them. The result of this evaluation will be a combined set of permissions that define exactly what the user is allowed to do when they access that socket, like what types of database queries they can run. Don't worry, we'll dive deeper into how this works in just a bit. Let's take a look at how a policy is laid out. High level, it has two main parts, permissions and conditions. All right, let's dive in and create our first policy, starting with the conditions. First up, we've got the Who section. Here, I'm going to add myself and the Octet group SRE. You can also reference a Google group, a local site reliability group, or any kind of SCIM group. It's pretty flexible. And if you're working with automation, you can add service accounts here too, which is super handy for things like bots needing access to a database or a Linux server. Next, we'll move on to the Where section. This part is all about where the user is coming from. You can set filters by country or IP range. For this example, I'm going to allow access only from the US and Canada. Finally, we've got the When section. I'll leave this blank for now, but this is where you can define specific date and time ranges. Just a heads up, the time is in UTC, so keep that in mind when setting time-based conditions. Now, the final step is to attach this newly created policy to the sockets we want to make available for these users. To do that, we'll head over to the Sockets tab here, and I'll just select all of them. Now, this policy is attached to all these services. All right, now let's go ahead and test this. Border Zero has a really neat built-in policy tester. You can find it in the menu here. Let's see how the policy will behave given a certain input. In my case, I'll use the usermat@borderzero.com and my current IP address, which is in Canada. If I hit test, we'll see the results on the right. Since it's all green, you can guess that means everything's good. Let's quickly go over the output. Starting at the bottom, it explains which parts of the conditions matched and why, and at the top, you see what kind of actions or permissions this user gets based on this policy. So, to recap what we've set up so far, anyone in the Octa group SRE, or specifically myself, Matt at borderzero.com, can access the resource, but only if they're coming from the US or Canada. Remember, only if all these conditions are met will the user be granted access to the resource. All right, enough testing. Let's see what we can actually connect to using this policy. There's a cool feature called the Access Graph, which lets administrators see exactly who has access to what services, given a specific policy. What we see here is our newly created policy in purple. And this policy gives us access to the sockets listed on the right, shown in pink. On the left, you can see exactly which groups and identities are covered by the policy, so you know exactly who has access to what services. Okay, time to connect to something. I'm going to connect to a Linux server using SSH. So I'll just go here and click connect. Let's try logging in as root, and voila, we're in. That was easy, right? But wait, maybe I shouldn't have root access. The cool thing is we can use the same border zero policy to control all kinds of application-specific things, including which SSH usernames can be used. So let's update our policy and only allow users to log in as Ubuntu. Don't worry about the other options yet. We'll get back to them in a second. All right, let's quickly check the tester again. And as you can see, it now shows that only the Ubuntu username is allowed. Next, let's connect to that same server again. First, I'll try using root, and as expected, it should fail. Yep, that failed. All successful and unsuccessful sessions are logged in the border zero portal. So let's check that out. Here you can see the most recent session with a denied icon, indicating access was denied. If we click on that, we can see more details about why it was denied. As expected, the user wasn't allowed to log in as root. Logging failed sessions is super useful because it lets you monitor what's happening in your infrastructure and helps to easily figure out why someone was denied access. All right, now let's try logging in as Ubuntu to make sure that works. This time I'll use my regular terminal to show you it works just as well, and there we go. I've got shell access as Ubuntu. Also notice there's a file called mysqldump.sql here. That looks interesting. Let me copy that over to my laptop using SFTP. I'll quickly go back to the sessions page and click on the green icon, which lets me see why I was granted access. It looks almost the same as the output from our tester earlier. If we look at the latest session, you can indeed see an SFTP action. Pretty neat, right? All right. That was easy and gave us lots of insights. But maybe we don't want users in this policy to be able to SFTP files from or to the server. This again is a perfect use case for our application-specific permissions. Let's go back to the policy and tighten things up a bit. First, I'll disable SFTP access. Maybe we'll also disable TCP port forwarding and allow SSH exec, but only for the command tail-f varlog messages. Now, if we try this again, you can see that SFTP fails. Let's also try an SSH exec. The tail-f varlog messages command works, but something like tail-f varlog syslog fails. Again, going back to the sessions log page, you can see the details of all these attempts and see whether they were successful or not. All right, so that's how Border Zero's policy engine makes managing SSH access super flexible and secure. We set up specific rules for who can log in, from where, and what they can do, all with just a few clicks. This isn't just about locking things down. It's about control, making sure only the right people can do the right things at the right time. And with the built-in tester and detailed logs, you get full visibility on what's happening. Simple, clear, and powerful. That's the Border Zero way. All right, now that we've covered how Border Zero helps you manage SSH access, let's dive into securing databases, since they usually hold our most sensitive data. So making sure the right people have the right access is rather crucial. And just like with SSH, Border Zero policies make it incredibly easy to fine-tune who can do what in your database environment. So here we have our database socket. We'll connect to it with the web-based client. As you can see, right now, I've got access to all databases across the environment. I can open any of these databases, and if I wanted to, I could make changes. But that's a little too much power for most users, don't you think? I definitely don't want everyone to see every database, especially if they only need access to one. Let's fix that by refining our policy. We're going to narrow this access down to just the database called books. This is perfect for a user who only needs to manage or view one specific part of the data. With Border Zero, we can control this at a really granular level. And just like that, only BooksDB is visible. The user won't even know the other databases exist. Simple, clean, and secure. But let's say you don't want this user to be able to make any changes to the data. For example, I can go ahead and delete a row here, which could be an accident or worse, an unauthorized change. That's not what we want. Let's go back to the policy and lock this down further. Now I'm going to update the policy again and set the access level to read only. This way users can view the data, but they won't be able to make any changes, keeping things safe and preventing those oops moments. Border Zero's database policies offer incredible granularity, allowing you to control not just which databases a user can access, but also the specific actions they can perform. For instance, you can allow users to select data from the books database, but prevent them from running any update or delete queries. Perfect for a read-only role. We bundled those into the read-only permission selected in our example. Now let's say we have a customer support team that needs to update customer records. With Border Zero, you can craft a policy that allows them to select, insert, and update data, but restricts them from running delete commands. This ensures they can assist customers by adding new information and making necessary updates, but without risking accidental data loss. You can even include commands like begin and commit to wrap changes in a transaction, allowing them to roll back if something goes wrong. This level of control ensures every user has just the right level of access. Nothing more, nothing less, keeping your data secure and your operations running smoothly. So now we've crafted a policy that fits the exact needs of our users. Let's see it in action. I'll try that same delete query again. And boom, access denied. Not only is the command blocked, but we can also see in the logs exactly why it was denied. This level of visibility is key. You're not just managing access, you're keeping a full record of what happens in your environment. So now we have a setup where users can only view what they need, and we've prevented any unintended or unauthorized changes to the database. And as with everything in Border Zero, you have full transparency with logs and session recordings to review who did what and when. That's how easy it is to manage database access using Border Zero's policies. Whether you need to grant full access or keep things locked down to read-only, you can do it all with a few clicks, keeping your data safe and your team productive. It's all about giving the right people the right access. That's a quick look at fine-tuning database access with Border Zero. Keeping things secure while giving users exactly what they need, whether it's full access, read-only, or something else. Border Zero makes it precise and controlled. And we're just getting started. Kubernetes is the backbone of modern infrastructure, and managing access to your clusters is just as important as securing your databases. But, just like we saw with the database, giving users too much access can lead to problems. So, let's see how we can lock down Kubernetes access with Border Zero using the same powerful policies we've been talking about. We've covered CLI login in another video, so I'll skip that. My Kubernetes config is set up, so I can jump right into using Kube to work with the cluster. All right, I've got full access to everything. I can see all the namespaces and have the ability to interact with any of them. For a lot of users, this is way more access than they need, and it's definitely more than we want to give by default. Let's head back to the Border Zero portal and refine this policy. Border Zero's Kubernetes policies offer incredible flexibility, directly mapping to the Kubernetes API, allowing you to control exactly what actions users can take and where. For example, you can provide developers with access to get, list, and update resources like pods and deployments in the dev environment namespace, mirroring their roles in Kubernetes to manage applications without impacting production. For security teams, you might set a read-only policy across all namespaces, allowing them to get, list, and watch resources like pods, services, and events to monitor the cluster's state without making any changes. And for operations, you could restrict exec access to specific pods, ensuring they can only run commands needed for troubleshooting without touching other resources. This direct mapping to the Kubernetes API helps maintain security and control while still giving teams the access they need to get their work done. Border Zero's rich policy language makes it simple to define exactly what Kubernetes actions users can take, on which resources, and by whom. In this case, I'll adjust the policy so the user can only list and get namespaces. Also, they will be able to list and get pods, deployments, and services within the dev environment namespace. Additionally, I'll allow them to exec into pods that start with shell. This setup is perfect when you need to ensure users have access only to specific environments without impacting anything else. Let's test this policy update by listing the namespaces. I can see all of them because the policy allows it, but I can only interact with resources in the dev namespace. Now, I'll try to exec into a pod with a name starting with shell in the dev namespace, and it works perfectly. But if I try to exec into pods starting with SSH or list pods in the prod namespace, access is denied. And since I can't see the pods, there's no way I could exec into them, even if I wanted to. This setup gives users the visibility they need without exposing or risking access to environments they shouldn't be touching, keeping everything secure and under control. And just like with databases and SSH, Border Zero logs everything, giving you full visibility into what's happening. In the session logs, I can see exactly who accessed Kubernetes, what they did, and when they did it. There are the exact actions that were taken during this session, everything from logging in to the commands that were run. This level of detail gives you confidence that your Kubernetes clusters are being accessed securely, and that you know exactly what's happening at all times. All right, we've covered a lot today. From SSH to databases, and now Kubernetes, you've seen how Border Zero policies give you control, flexibility, and security across your infrastructure. Whether it's limiting who can log in, locking down database access to read-only, or narrowing Kubernetes access to a single namespace, Border Zero makes it easy to secure your environment without slowing down your team. Thanks for watching. I'm Matt, and see you next time.